So welcome to Unraveling the Knot, clean and testable client-side code. When Manny asked me to talk today on single-page web applications, I decided I wanted to present something that you'd be able to take with you and implement immediately when you get back. That's going to make your code cleanable and a lot more testable. And because a lot of times when I come to these talks, I get shown a new framework that implements JavaScript in a new way and does some sort of functional programming or something that looks cool but isn't something I'm going to be able to use. So why are JavaScript programs such a mess? Well, when JavaScript started off with, all it was used for was to basically animate buttons. There is and it had events embedded in the HTML with on-click, on-mouse over, on-mouse out events. Then came the age of the JavaScript libraries, Prototype, jQuery, MooTools, or many others that basically let us write less and do more, like jQuery says, and encouraged a lot of moving code to the client side. Instead of implementing slideshows where you pressed on the next button and it reloaded the entire page, it would just show you the next image. So the code started to look a lot like this. The code was separated from the HTML and put in another file. And all you do is go and grab a DOM element and then attach an event handler to it and do some stuff with it. This worked well for some very basic functionality. But once you started to build anything that was more complex, it started to create chaos because the intertwining widgets caused code complexity to grow exponentially until it became impossible to keep up with an application of any decent size. So that brings us to today, which I'm now dining, the age of the single-page web application. We've really moved past just basic frameworks like jQuery and Prototype and MooTools. jQuery won that one. Now jQuery is hidden behind the scenes a lot of the time behind a different framework. Some of the most popular, Angular, and there's some that attempt to do even new things like Meteor and Derby, which try to make writing the front end and the back end part of one code base. And then there's lesser known ones like CanJS. All of these single-page web app frameworks attempt to do one thing, and that's to bring order to the chaos of the JavaScript on the front end. They all have success in varying degrees at doing this, but usually you end up with this. It piles up your spaghetti code and sticks a meatball on top. And the meatball on top is, for me, the model object that automatically interacts with AJAX with the server and keeps your client side and your data up to date on the server. That's really handy. It's really nice to have that, not be able to have to code that by hand. But these frameworks don't give you the overall picture of how do we organize this code. If you've worked on 5 different Angular or 5 different Bootstrap or any of these applications, you've probably seen 5 different ways to organize your entire code base. So today I'm going to show you one technique that will definitely work, maybe, no matter which framework you use, to get a clean and organized code. You seem skeptical. How could one simple technique fix everything? Well, maybe it won't fix everything, but it's still pretty good, and it'll get you a long ways towards having an organized and testable code base. So the single-page web application is comprised of many, many, many different parts. Routing, templating, data storage, state manipulation, obfuscation, concat, on and on and on and on. So what one part can we pick out of this that's going to help you organize your code and clean it up, make it testable, regardless of which application or framework you're using? Interestingly, it's the data storage. It's how you store your data in the client. So, of course, this goes back to the quote by David Wheeler, all problems in computer science can be solved by another level of indirection. It's true here as well. So first, let me demo a basic application for you. So here we've got an application of moderate complexity. You can see up here on the left, you've got your date widget. You've got your KPI widget right here. You've got your chart that needs updating, and you've got a table down here that puts in text format the chart here. You update things. All right, chart updates, table updates, KPI updates. Click on things. Okay, now the date updates, the KPI, oh no, KPI didn't update. And that's going to be because of some intertwining independencies that make it very difficult to update all the widgets that you're supposed to. I actually coded this bug on accident in here and found it and said, hey, it's a perfect example of a typical application. So here's the code for that moderate complexity application. Don't read the wall of text. It's basically just 4 different objects: a chart object, a date object, a KPI object, and a table object. I'm using the word object here in sort of an abstract sense. They're really just event handlers on these widgets. So now highlighted in red is where the object refers to a different object. And so this is talking about the intertwining interdependencies. You can see that the KPI here is being updated when the date selector changes. So the date selector is directly manipulating the KPI object. The KPI object directly manipulates the date object and the table. The table updates the date, and the date updates everything else. So, complexity. So, I'm going to show you, here's another view of that complexity. So we just remove all the code and just show how everything complicates everything else. And the way we're going to fix that is with the data store pattern. So now, when the KPI or the date updates, it's going to update the data in the data store. And the data store object is responsible for updating the different components. And what this does is it removes from, it makes it easier to update your code base. It makes it easier to change the date object. Suppose you, instead of a select, you wanted to add a calendar widget. Well, if you're dealing with this thing here, you're updating every single widget that you have in your application in order to change out your date widget. If you're dealing with this, you can just remove the date widget and stick in another one. I'll show you why that is in a little bit. But first, I'm going to talk about observables. So observables are objects that when an attribute on them changes, you can attach an event handler to it so you can do something when something on that object changes. I'm using CanJS because I really like its observable pattern, and it's actually my favorite front-end framework today. So there are 3 ways to observe objects in JavaScript today. The first way is to muck around in native object prototypes. And I think that was proven a bad idea way back in prototype versus jQuery days. But if you think it's a good idea, come up and talk to me afterwards. I'd love to hear why. The second way is to have an asynchronous event loop watching native objects. And so this has the benefit of you're still able to code with native objects. Your object is an object, your array is an array, and your values, numbers are numbers and strings. But it has the drawback of now you've added an asynchronous event loop watching the thing. An asynchronous program is one of the most problematic and difficult coding environments to work in. As front-end developers, we might be a little bit used to it by having to do a bunch of callbacks and callback hell from AJAX requests and from event handlers. But that's also responsible for a lot of complexity. I've had a lot of difficulty taking a library that's not asynchronous in nature and hooking it into a framework that has this asynchronous event loop in it. And the third way, which is what CanJS does, is it creates a new observable object type. So it just takes your basic objects, arrays, and numbers and wraps an observable thing around it so you can use it. Then there's a bonus way coming soon-ish. Object.observe in, I think it's ES6 has a way to do this, but when I wrote this presentation, at least, it was only available in Chrome, so hopefully they'll roll it out to the other browsers so we can use it in 2 or 3 years. All right, so CanJS observable objects. A plain old object is a can.map. A array is a can.list, and a value, such as a number or a string, you can make observable with a can.compute. So reading from a map, at the top here, here's what a plain JavaScript object looks like. You're used to those. So you just take that plain JavaScript object and you stick it in a new can.map constructor, and now you've got an observable object. You just call map.adder to get the object back out, or map.adder attribute name to get the value of the attribute out. So you have to access it with an accessor method. So that's a drawback over the asynchronous event loop way, because you can't just access it with the dot notation. But yeah, small overhead. Setting a map's properties is done using the standard pattern that jQuery popularized, which is if you pass in a second parameter that sets it, if you don't, it gets it. And here's the observable bit. If you want to observe changes on the entire object, you just say map.bindChange and pass in a function to do something with. If you just want to see when an attribute changes, you map.bind on the attribute, and you pass in a function that you do something with the change. Simple. All right, enough about CanJS and observables. Back to the data store. So there are 5 steps to implementing a data store in your application. The first is to create the data store. Second is to identify any interdependencies. Third is to move data to the data store. Fourth is to bind to those data changes. And fifth, update the data store. So the first step, create a data store. Very difficult, complex process. So complex, I've removed all the other objects except for a chart object and a data object, so you can see what I do. All right, data store created. I just use a plain object to hold it, and then I put the observable objects as attributes on that. You can make the whole thing a map if you want to, but I sometimes store things in the data store I don't want observed, and so I don't want those turned into observables. So all we've done now in the first step is added a data store. That's it. We still got all of our interdependencies around. All right, step 2, identify an interdependency. All right, here's the full code set again with the data store added. We actually already identified an interdependency earlier, so we'll just use that. That is where the date selector is referring to the KPI object. And the reason it's referring to the KPI object is because it needs to update a value that's determined when the date selector changes. Interdependency identified. All right, so third step is you got to move that data to the data store so you can access it. So here's our data store. There's our data, and we just take it and move it in and set it to datastore.value is now a compute. So value is now an observable object, and it's set to a default value of 0. Fourth step is we're going to bind to data changes. So here's our objects again and our data store. And here is the computes event handler. Data store.value bind to changes on the data store.value. And then we take that dependency that's inside of the date selector, and you just move it on over into the event handler. So now, when the data store updates, it shoots the change event, which updates the KPI element. So now we've taken this date selector dependency, and now the data store is updating the KPI. So let's take a look at what that looks like. Page here. All right. And I code. Can you see the bottom of the code there? Not very well. Anybody know if there's a way to make this text bigger? All right, that didn't work. Option scroll. Oh well. All right, let me move this up here then. So in the code here, I called it data set instead of data store. Sorry about that. Okay, so we got dataset.value, and we're going to set this to 99. Right here, you can see the KPI is set to 93, and that's what we updated by moving it to the data store. And hey, look at that. Data store updates. And you can set anything you want in here, and it'll update. So now we've separated the KPI widget from the date widget. And this actually helps immensely in terms of testing as well, because now you can test the KPI widget separate from your date widget. Before, you had to go in with your test and update the date widget and see if the KPI updated. Now you can just update the data set directly and test to see if the KPI updated like you wanted it to. But unfortunately, so far anyway, we haven't hooked up the date selector to actually do that update. And so that is the fifth step, update the data store. So we just have that same line of code there in bold, KPI HTML new value total, and we just replace that with updating the data store with the new value. And that's the process of updating to the data store pattern. So now let's walk through how this code works step by step once it's fully implemented. So you've got the date selector change event handler. That change event handler updates the data store's value. The data store's value is an observable, which we have bound to, and then we update the KPI object. So code is broken up into two easily testable stages. Does updating, you can ask two questions now. Does updating the date selector update the data store? Then you just call the code to update the date selector and then check to see if its value is updated in the data store. And two, does updating the data store update the KPI widget? You just encode update the data store and then check the KPI widget to see if it has the correct value. So now you just repeat these steps. Identify the interdependency, move data to the data store, bind to data changes, and update the data store. Identify, move data, bind to data changes, update. Very, very easy to remember acronym, IMBU. Okay. That's easy to remember because it's a fruit found in Northeast Brazil, renowned for its sweet taste and distinct aroma. Imbue. All right, imbue, identify, move, bind, and update. So once you've done that to your data object, this is what it will look like. In red here is all the old dependencies that you had on the other objects. And now you've updated them all into the date selector. You'll see that I'm not actually directly editing the data store.value anymore, because I found out that once I started moving things to the data store, the value is actually dependent on something else. It's in a separate event handler. And so data store.data pushing this data on there will do an event handler that updates the value, that updates the KPI. So that's no longer something that the data selector directly changes. So once you've imbued your entire application, we'll be at the data store pattern that we had spoken about. And so this is what the code will look like for the fully implemented data store. You'll have the data store object. We've got 4 values. 3 of them are can.computes. 1 is a can.list. And then you've got your 4 event handlers, and none of them are referring directly to the other objects anymore. They only refer to the data store. Now it might look like this is, okay, there's less code now, but we've actually just shifted the code that was in these event handlers off stage. This pattern, actually, you get a little bit more code because you have to do the overhead of doing the data store and binding. But with that little bit more code, you get a lot more in terms of being able to clean up and maintain your code base. So here it is. If you click on a cell on the table, it's going to update the data store. So in this case, we're updating selected. That will execute this change event handler. In this case, we've gone a step further and we've actually done some object encapsulation. We've saying the table object is responsible for what it means to be active. So that if we want other things to make it active, we can just call table.active as well. So you can apply this pattern on top of other well-known and well-used patterns. All right. Demo. So we've got our data set. And in here you can see we've got our data at our selected and our values. Let's play around with these a little bit first. And you can see that that bug that was there before, when you had all those interdependencies, is gone now that I've made it into this much simpler pattern. That was also by accident. Happy accident. So now you can go in, you can access the data directly and say, okay, what's my data set.value? It's 59. It's 59. Okay, well, what happens when I update that? Here it updates it. And what is this selected parameter? So I got a 7. So what happens if I change this to 3? Notice that selected is what the date select. It controls the date selector. It selected the third one here. It updated the table to be the third one, and it changed this KPI to be the value of the third one. And let's see what else there is. Total header. This is a poorly named one. What is this? So this has a value of 0. Happens when I give it a value of 1. So this is what happens when I roll over the KPI. It highlights which title we're talking about. And so now you can control that manually to test it as well. And you go over. It's there. It happens. All right. So 5 steps to the data store. Create a data store. Identify interdependencies. Move data to the data store. Bind to data changes, and then update the data store. You've now got a much cleaner and more organized code base. All right, thank you.